Okay, so we're going to round these numbers to one significant figure. So 6.32 is going to round to 6, 6.51 rounds to 7, and then 0.503 to one significant figure on the bottom is 0.5. Now whenever we've got these, we've got to work out what's on the top and what's on the bottom. So on the top there, 6 times 7 is 42, and it's 42 divided by 0.5. Obviously, if that was a nice little division there, we could do that straight away, but dividing by a half does something in particular. So dividing by half actually doubles your answer. If you think half fits into 1 twice, so it'll fit into 42 84 times. So there we go, dividing by 0.5 doubles our number. Obviously if we had something like 3 on the bottom or something like that, that'd be a little easier, but dividing by 0.5 doubles our answer. So that's estimating. Just remember to round to one significant figure and then to complete your sums that way whenever you see that word estimate. So write 180 as a product of prime factors and give your answer in index form. So we can do our nice little prime factor tree. And again, thinking of any two numbers that times to make 180. So I'm going to go for 18 and 10. 10 becomes 2 and 5, locking off those numbers when we see that they're prime. 18 is 2 and 9, and 9 is 3 and 3. And again, locking those all off when they're prime. Remembering you can write down some of the prime numbers if it helps. Now writing these in size order, we get 2 times 2 times 3 times 3 times 5, and then we can simplify these. So 2 times 2 becomes 2 squared, 3 times 3 becomes times 3 squared, and then times 5 at the end, and that's in index form there using indices. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is. I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each? So that is one on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils. So that's 8 packs of pencils. 8 packs of pencils. And below there we have 1, 2, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90, 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 doesn't, 8 doesn't, 9 does. 9 and 10, now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18, we don't have to do all the factors of 72 there because we've spotted that it's 18. Of course we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3, and that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. Okay, so on the number line, show this inequality. So when we're drawing these sorts of things on a number line, we look at what numbers we've got. We're going to put our little circles above those, so -2 and 4. And we're going to join them up. And then we just need to have a look at these symbols. So the one here, which is less than or equal to, we're pointing towards that less than or equal to, it has more ink on it, so we just remember to colour that one in. Make sure the circle has more ink in there as well. Nice little way of remembering it. There we go. So that is between -2 and 4. Remembering that is equal to -2. So the numbers that this could be is we could have -2, -1, 0, 1, 2, and 3, but not including the 4 there because it says less than 4. So you can have an inequality like this as well, where it just says x is greater than or equal to 1. So again, putting our circle above the 1, the greater than or equal to has the extra ink on it, so we'll colour that one in. is equal to that as well, and greater than 1, so we'll just point an arrow to the right saying it's got to be greater than 1. And that's that for that type of inequality. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%. 10% is £64. 20% will be double that. So double that is £128. So that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%. Dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, so a mobile phone is reduced by 20% in a sale. The sale price is 500, work out the original price. So this is a reverse percentage. It's asking us to work out the price in the past. Now I like to draw this in a slightly different way. I want to identify what percentage is this 500. So if it's been reduced by 20% in a sale, well, that means that we have the 80% of the cost and this 20% reduction, if I think of this in terms of two little bars. So I've just got to think, which percentage actually is this 500? Is it the 80% or is it the 20%? Well, the sale price is the amount that we're paying, so not the little 20% sale. So that £500 equals 80%, and I always like to write this down. Now we don't want to know what 80% is, we want to know what 100% is. So I just need to think, how do I actually turn this back into 100%? So if we've got a calculator, this is nice and easy because we can divide that by 80, which will give us 1%. And if we do that on a calculator, 500 divided by 80 gives us £6.25. Okay, so 500 divided by 80. So if we have a calculator, we can do that. We can do 500 divided by 80. That tells us 1% is £6.25. And then we can times that by 100 to get 100%. And that would be 100% what we're looking for, equals £625. Oh, that's not a six, £625. Okay, if we don't have a calculator though, we're going to have to think of a different way of doing this. So what we can do is think about actually just dividing this by something to maybe get 10%. And you can divide 80 by 8 to get 10%. So if we divide 500 by 8, we'll also get 10%. And we can do that using a bit of a stop. So off to the side, if we didn't have a calculator, 8's into 500, 8's into 50 goes 48. So it would go in 6 times up to 48 with a remainder of 2. It would go into 20 twice up to 16 with a remainder of 4, so we'd have to carry that over. And then 8 goes into 45 times, so we get that 62.5 as 10%. So 10% is 62.5. And then we can times that by 10 to get back to 100%. And 100% there would be £625. So we get there either way, but that's two different ways of looking at a reverse percentage where we're looking for something in the past when there's a sale going on. Okay, so the other way around, a house rises in value by 3%. The value of the house increases by 7,500. Work out the value of the house before the increase. So when it's been increased in value, again, we can visualise this. We've got the original price, which is our 100%, and then it's rising in value by this extra little 3%. So again, identifying what is this 7,500? Is it the original 100% or is it the 3%? Now it says it rises, it increases by 7,500. So that 7,500 is my 3%. There you go, and again we want to know 100%. I can't straight away times 3 to get to 100, but I can divide both of these by 3 to find out what 1% is. And again, we can do that on a calculator or using better bus stop, but 7,500 divided by 3 is 2,500. So 2,500 equals 1%. And again, we can times that by 100. So over here, if 1% equals 2,500, we can times that by 100 to get our 100%. So 100% will equal 2 500 with another 2 zeros, and that's 250,000. So our answer there would be £250,000. So £800 is invested for 2 years, offering a 1.5% simple interest rate per annum per year. How much is in the account after 2 years? Now, simple interest means it doesn't keep accumulating. So if we first work out what 1.5% is, again, if you haven't got a calculator, we can do this non-calculator. So 10% of 800 would be 80. 1% would therefore be 8, and 0.5%, which we're going to need there, is 4. So joining those two together, the 1 and the 1.5 gives us 12. So we get £12 there for our 1.5%. Now we can do this using a calculator as well, which I'll discuss in a sec, but if we're going to get £12 per year, simple interest just means that's what we're going to get per year. So if it's 2 years, we'll times that by 2, and we will get £24. So that's the amount of interest we'll earn. It does say how much is in the account though, so if we add that back into the account, we'd have £824 as our final answer. Now if you've got a calculator here, you can always use a multiplier method. So we could do 800 and we could times it by 1.015, and that gives us the answer 812, telling us that in that first year there we've earned £12 interest. So adding in another 12, so add another 12 would give us 824, the same answer. Okay, or you could times it by 0.015, and that would have just straight up given you the 12, and you can add that on for how many years for simple interest. When it comes to this sort of question, Emily invests £150,000 in a savings account offering a compound interest rate of 2.4% per annum per year for 4 years. Work out the amount of interest that she earns. So I'm just going to underline that, the amount of interest, so a slightly different part of the question here. So compound interest does keep accumulating, so she earns more in the second year, more in the third year, in the fourth year, but we can take a very similar approach. We do 150,000 times it by 1.024 for 2.4%, and rather than finding out what that is and repeating myself, I'm going to do it to the power of 4, and that'll just keep timesing it by 1.024, adding on that 2.4% every year. And if we type that into a calculator, 150,000 times 1.024 to the power of 4, we get the answer £164,926.74 to the nearest penny. Now just being careful on this question, because it does say how much interest does this person earn, does Emily earn, so we're going to want to subtract that original 150,000, so take away the 150,000 for this particular one, and that gives us £14,926.74 again to the nearest penny. So there's a bit of compound interest, just remembering this multiplier here and how that works with compound interest, not forgetting the 0 there, and putting, because if we were to put 1.24, that would increase it by 24%, so we don't want that one there. So Mary buys a car for £4,000. Each year it depreciates by 20%. Work out the value of the car in 3 years. So that word depreciate means it falls in value. Now again, with depreciation, it's similar to compound interest. It falls in value, but it falls in value based on its new price. So if we do this without a calculator, and we can do it both ways. Year 1, the £4,000 is what it's worth. 20% of that we can work out. 10% is 400. 20% is 800. And if we take away that 800 there, so 4,000, take away 800, we end up with 3,200. So we don't keep losing £800 a year. Now in the second year, it's worth 3,200. 10% of that is 320. 20% of that is double that, 640. And we could subtract 640. So 3,200 take away 640. Will leave us with our answer for the final year. Take away 640 there, gives us 2,560, and we can finish this off, or I should have said year 2, we can finish this off on year 3. So our value is 2,560, 10% of that is 256, so 20% will be 512, and then we can subtract 512, so 2,560 take away 512 leaves us with a final value there of 2,048. £2,048, and that'd be our final answer. Again, we could do this with a calculator. If something loses 20% in value, then it's only actually worth 80% of its cost the previous year. So if it's worth 80%, the decimal that I can use for 80% is 0.8. If it's losing value, we won't want a 1-point number there, we've got 0.8. So we could just times it by 0.83 times, or times it by 0.8 to the power of 3. So I could just type into my calculator 4,000 times 0.8 to the power of 3, and I'll get that answer there, 2,048 as my final answer. And let's test that out. 4,000 times 0.8 to the power of 3, and we get 2,048. So that's depreciation. Okay, moving on to fractions, multiplying and dividing fractions. Multiplying fractions is the easiest one, isn't it? So we can times the top numbers, 3 times 2 is 6, and times the bottom numbers, 4 times 3 is 12. And we always want to simplify our answer, and a question will normally ask us to write it in its simplest form. So here we can divide the top and bottom by 6, and we get 1 over 2 as our final answer there. So always looking to simplify. On to the next one. We keep the first fraction the same, we flip the second one over, and we multiply them together. So times in the top numbers just like before, 2 times 5 is 10, 1 times 9 is 9, and again we'd normally be asked to write our answer in its simplest form or as a mixed number, and here it is an improper fraction. 9 fits into 10 once, with a remainder of 1/9 left over, so 1 1/9 would be my final answer there, and that's dividing fractions. When it comes to adding and subtracting, the process is the same. I'm just going to go for this one addition. So when we're doing this, we need to obviously look at the fact that there is a mixed number here, and we're going to make that into an improper fraction first, and the same goes for multiplying and dividing. So we're going to do 1 times the 4, the big number times the bottom, and then add the top. So 1 times 4, add the 3 is 7/4. And we're going to add to that this 2/3, and again if that was a mixed number we'd also convert that into an improper fraction. Now we need a common denominator when we're adding and subtracting, so that's going to be 12 on the bottom, so we can times this left fraction top and bottom by 3, and we can times this right fraction on the top and bottom by 4, and that's going to give us 2 fractions out of 12, so 7 on the left times 3 is 21 over 12, and on the right 2 times 4 is 8 over 12. And now we can add these together, and again if we were subtracting them we'd just subtract those numerators now, but we'll add them together and we get 29 over 12. And again it says to give your answer as a mixed number, so we are going to convert this now into a mixed number. 12 fits into 29 twice up to 24, and there'll be a remainder of 5/12. And again there's my final answer. Just be very careful at this point just to have a look. Does this fraction simplify here, the little one? It doesn't, but let's imagine it was 4/12 there instead of 5/12. That would actually simplify, wouldn't it? Because if it was 4/12 we could divide the top and bottom by 4, and that would end up being 1/3. So just have a look in that situation. Does it simplify? This one obviously doesn't. It's 2 5/12. Let's have a look at another one. So in a bag of counters, 2/5 are blue, and it says 18 are blue. Work out the total number of counters in the bag. So it's not asking us to work out 2/5 of a number, it's saying that 2/5 are 18. Remember, it could have said work out 2/5 of, let's say, 20, and you divide by the bottom to get 1/5, you'd say that 1/5 is 4, and then times by the top to get 2/5, and we'd get 2/5 would be 8. That's a different question, so it's nothing to do with that, but it says 2/5 are blue and 18 are blue, so 2/5 equals 18. So if I want to work out 1/5 in this scenario, I need to divide by the top this time, because that gives me 1/5, half of that. So 1/5 would be 9, and then to work out 5/5, the original amount, we could times that by 5. So times it by 5, and we would get 5/5 equaling 45 counters. There you go, so that's our scenario there. So slightly different the other way around, obviously, to working out a fraction of an amount. It says that that fraction is 18. So dividing it by 2 to get 1/5, and then timesing it by 5 to get the original amount. Okay, so writing some numbers in standard form. We're going to make this a number between 1 and 10, times 10 to the power of however many jumps we have to do in whatever particular direction. So this number here, 5,600, I'm going to hop the decimal in between the 5 and the 6. So 1, 2, 3. So that becomes 5.6 times 10 to the power of, it's a big number there, it's not a 0-point number, so 10 to the power of 3. Final answer. The next one is a small number, so we're going to have a negative power, because we hop the decimal the other way this time. So 1, 2, 3 would make it 3.4, and again this time it would be times 10 to the negative 3, because it's a 0-point number, that indicates that it's a small number. When it comes to the other way around, writing them as ordinary numbers, I like to rewrite this little bit at the start to start with. So 2 and 3, and I like to just imagine where that decimal is between the 2 and the 3. So times 10 to the power of 5 makes it a big number, so we need to hop it 5 places. 1, 2, 3, 4, 5 to the right, and then filling in all those zeros underneath. And if it is messy, just remember to rewrite that. But there's my answer, 230,000. The next one, 8.04 times 10 to the negative 3. So this is going to be a 0 point number. And again, I'm just going to write these digits out at the start, these bits here, and imagine where the decimal is at the top, 8.04. So negative 3 means it's going to be a small number, so we're going to jump it left 3. 1, 1, 2, 3. So it's going to go there. Fill in all the zeros and tidy it up at the start. So 0.00804, final answer. Okay, so write this as a power of 3. So when we've got the same base numbers, which we do, these are all 3s, we can add the powers when multiplying and subtract the powers when dividing. So if we tidy up the top to start with, which I always do first, we add the powers there because they're getting multiplied. So 3 to the power of 7, and on the bottom, we've got 3 to the power of 3. Now these are being divided, so we can subtract the powers. So 7 take away 3 is 4, so we get 3 to the power of 4. And again, it doesn't say to work out the value of that, it says to leave it as a power of 3. If it said work out the value of it, I'd actually have to work that out, and that means 3 times 3 times 3 times 3. Wouldn't be very nice without a calculator, that one, but we could work it out. But it says to write as a power of 3. Okay, so negative and fractional powers. Remembering the negative symbol there just means to do the reciprocal, to flip it over. So in this first one, if that's 5 over 1 at the moment, it'll become 1 over 5. Now if it was just a negative 1 in the power, we'd leave it as it is because it would be a power of 1, but that 2 is just a normal power, which means we're going to have to square both of these. It's a normal squared power. So 1 squared on the top is 1, and 5 squared on the bottom is 25, and that's our final answer there. Onto a fractional power. Remembering that number on the bottom of the fraction represents a root. So in the case of a 2, that is a square root. So we're going to do the square root of 64, and the square root of 64 is 8. Now the 1 on the top is a normal power, so a normal power of 1 doesn't do anything. But if it was a 3, for example, we'd have to cube it, but it is just a 1. There's no negative in that one, so we don't have to flip it over or anything. It's just the square root, which gives us the answer 8. Okay, on to some combinations. It says in a bike store there are 8 different bikes and 10 different choices of paint colour. How many different combinations are there? Well, we have 8 choices of bikes to pick from, so that's 8 different combinations. And all we do is we multiply it by however many choices we have on the second option. So the second option is the paint colour, and there are 10. So we times it by 10 as our second option. So 8 times 10 gives us 80 options as our final answer. So you just take how many choices you have on each pick and multiply them together, and that's combinations. Okay, so this one's slightly different. A 3-digit padlock uses the numbers from 0 to 9. How many of the possible 3-digit number combinations use 3 different digits, meaning we can't have any repeats here? So let's imagine on the first one, on the first digit of this padlock, let's imagine we've got 3 numbers. And on that first digit, let's say we pick the number 2. Now in that first pick there, we had the numbers from 0 to 9, including 0, so that would be 10 options that I had. But now that I've picked the number 2, I can't pick the number 2 again because there's no repeats. So I don't have 10 options now, I only have 9 options. Let's imagine we pick the number 3. So on this option now, on this third pick, I can't pick 2, I can't pick 3 out of these 10 numbers, so I only have 8 to choose from. So they are my 3-digit padlocks. Let's just imagine we pick the number 4, 2, 3, 4, and we'd have to multiply these all together. So 10 times 9 gives us 90. Well, we've got to times by 8, and 8 times 90, well, 8 times 9 is 72. That's not a 7. 8 times 9 is 72. So 720, and that's how many different combinations we'd have for this particular padlock. So 10 times 9 times 8, perfect, 720. Okay, some error intervals. 6.4 has been rounded to 1 decimal place, and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to 1 decimal place, it couldn't have been 6.45. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number, that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away. So it would be 6.05. 6.35. Okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to one decimal place. On to the next one. This one's slightly different in the wording. So this one says it's been truncated to one decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5 because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So two different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all. And the final little one we're going to have a look at here is using your calculator. So it's important to know where lots of digits are. Pick quite a complicated one here, but you just need to have a play around with your calculator to make sure you can find your square root, your cube root, your squared, your cubed, your fraction button, your sin, your cos, your tan, and figuring these out. So I picked quite a complicated one here. So to get your cube root button, depending on what calculator you have, but the majority of them you still have to press the same things. We press shift and then we go for, let's get a different colour here, we go for the square root button, and that allows us to get a cube root. So on your calculator, a cube root will pop up, and then we're going to use the fraction button. So the fraction button is just next to it in this diagram here, the fraction button, and an empty fraction is going to pop up. So on the top, we're going to just type in on the top of that fraction there, 4.3 multiplied by, press your tan button, and then press 39, and normally this will go in a bracket, so remember to close the bracket off there. But you don't put this little degrees symbol in, you just put 39, the calculator knows that you're talking about degrees. So let's get that up on my calculator. We've got 4.3 multiplied by tan, the brackets opens for me, 39, close the brackets, press your down button on the calculator to go into the bottom of the fraction, and type this sum in here, 23.4 take away 6.06. So 23.4 take away 6.06, and make sure at this point you write all the numbers down. That equals 0.5855934233. Now some calculators may go beyond this depending on what the answer is on the calculator, but it tends to be that you never really have to go beyond 9 digits because not all calculators will go that far, so you are limited to the amount that some people will be able to write depending on what calculator they use. Now the question will probably usually say then to round your answer to 1 or 2 decimal places. So if we just have a quick think, if we were to round this to 1 dp, to 1 decimal place, and we could chop that after the 5 there. So 1 decimal place would round up to 0.6, and we would round that to 0.6. If we had this to 2 decimal places or beyond, let's have a think. After 2 decimal places, let's pick a different colour. It would chop it after the 8, and it would be 0.59 because it's a 5 after that one. Okay, so you could have different ways of rounding this, but just make sure you write down all the digits on your calculator display before actually rounding anything. Okay, so kicking this off with fractional and negative indices. So you've just got to remember, looking at this one on the left, if there is an indice, the negative does the reciprocal, which I always just write as a flip. The bottom is the number underneath, which does the root, and then the number on the top is just a normal power. Okay, so I'm just going to put power with that, so normal power. So for this particular one, we've got all 3 going on. So I always start with flipping it over, doing the reciprocal, and remembering that 8 is just a number, so we could write that as 8 over 1. So when we flip that over, it becomes 1 over 8. Then we've got to do either the root or the power. I always like to do the root first, make the number smaller before trying to then do the power. So a 3 on the bottom would represent a cube root, so we need to do the cube root of both of these numbers. The cube root of 1 is 1. And the cube root of 8 is 2. 2 times 2 times 2 is 8, so it's 1/2. Then we've got to finish it off. We've still got to do that normal power there. If it was a 1, it wouldn't affect it, but a 2 as a normal power is squaring. So if we square them both, we get 1 over 4, as a final answer. And just remember to follow all those rules. Now looking at the one on the left, we've not got a negative, so we don't have to flip it over, but we have got a 2 on the bottom, which is the root again, and a 2 is a square root, and then we've got a 3 on the top, which is going to cube the numbers. So if I start with the roots to start with, if I do the square root of both of these, and it's always a little hint there, they are square numbers, the square root of 9 is 3, the square root of 100 is 10, and then we've got to actually cube them as well. So if I cube these as well, let's write that in, 3 cubed is 27, and 10 cubed is 1,000. So it'll be 27 over 1,000. Just being very careful to get those right. So that's negative and fractional indices. Okay, so when you see this sort of question, you see these words here about bounds, there's always something we need to write down straight away. So we've been given 2 numbers here, so S is correct to 2 decimal places and T is correct to 1 decimal place. So the first thing I'm going to write down is the error intervals for them before I move any further. So writing our error interval, arrows pointing to the left, and an equal to symbol on our lower bound there. So I always start with the upper bound and I just stick a 5 on the end, so 8.24 with a 5 on the end, and then we just need to take that 5 off for the lower bound, so it'll be 8.2, not 4 but 3 with a 5 on the end, and then do the same for the other one as well. So let's write down the upper and lower bound for 3.5. So 3.5, stick a 5 on the end, and then for the lower one, drop it down to a 4, and again just stick a 5 on the end. Now this question here asks us to find the upper bound. So when it comes to a fraction, and you could have anything here, but when it comes to a fraction, if we want to get the biggest possible answer, we want to do either, we've got to decide here, either we're going to do the upper bound divided by the lower bound, or we're going to do the lower bound divided by the upper bound. And we've just got to think which one there is going to give us our biggest possible answer. And that is the upper bound divided by the lower bound. So we want the biggest number on top divided by the smallest number, and that'll give us our biggest possible answer. So we want the upper bound of S sitting on top, so the 8.245, and the lower bound of T, 3.45 sitting on the bottom. So this is a calculator question. So we just need to type that in on the calculator, 8.245 divided by 3.45. and see what we get as our answer there. So if we type that in, 8.245 divided by 3.45, and we get the answer. It's quite a lot of decimals here, 2.3898557. Always just write down all the numbers and then round it however you've been asked in the question. This one says 3 decimal places, so let's chop it after the 9, and that would go to 2.3, and this is a bit of a dodgy one because the 8 rounds the 9 up, so it would go to 2.390, keeping the 0 in there. It does say 3 decimal places, so 2.390 would be my answer there. Okay, obviously it might say lower bound as well, in which case you'd use the other side of the formula, would you use this one instead. You might even be asked to do both of them and then round it depending on what they both look like. So if we imagine that the lower bound comes out as, and if we just make something up here, let's imagine the lower bound comes out as 2.295 or something like that. Now it might say considering bounds, give your answer to an appropriate degree of accuracy. And if you look at both these numbers, if we just imagine this is the lower bound, it's probably not, but if we imagine it was, these two numbers would not round the same to 2 decimal places, not to 3 decimal places, not even to 1 decimal place, because the one on the left there would round to 2.4 and the one on the right would round to 2.3. So if I did have to consider bounds to give an answer for this, I'd just have to say 2. And I would say the answer is 2, and that would be to 1 significant figure. So I could be asked that as well, and I just look at the upper and the lower bound and I round according to how they both actually round. And in this case, my little example here, they only round the same to 1 significant figure. Okay, so recurring decimals as fractions. So a little rule, we are going to use a bit of algebra for this, but if there's 2 recurring decimals, we're going to times it by 100, and if there's 1 recurring decimal, we times it by 10, and so on. There's lots of different ways of doing this. This is just the way that I do them. So I write what the decimal is. So we've got x equals 0.54. And remember, if there's a dot above the 5 and the 4, that means that that decimal there is 0.5454, and continues like that. It's the 54 that's recurring. It's always good just to write that down, just to remind yourself what that decimal actually represents. So if we've got 2 recurring decimals, we can times that by 100. You'll see why if you've not seen this before. Hopefully it's just a reminder. You get 54.54. Now we can take them away from each other, and that'll eliminate these recurring decimals here. If we take them away from each other, we have 99x's equals 54. And make sure that you actually do use your algebra to show this. Now we can divide both sides by 99, so x equals 54 over 99. And there it is as a fraction. You do just need to just check just to see if your fraction simplifies. So do check to see if this one simplifies. This one actually does. The top and the bottom both divide by 9. And you'd normally be asked to show that it equals this next one. But if it doesn't, you know, you can look to simplify if it says to give it in its simplest form. And if you divide them both by 9, you get 6 over 11. So the question might have said show that it equals 6 over 11. And that's how you would show it. You'd show how it simplifies. Now on to the one below. It's only got one recurring decimal, but it's a bit of a nasty one. So if we think about what this decimal actually looks like, 0.23 with the dot above the 3, that's 0.2 and then a recurring set of 3s. It's not a full repeating pattern of 2, 3, 2, 3, 2, 3. So if we have a look at this one, and again there are different ways of doing this type of question here, but this is I just follow the same process for all of them. So x equals 0.23 with a dot above the 3, and there's one recurring decimal, so let's times it by 10. So we get 10x equals 2.33, and then the 3 keeps going. I'll just balance it out so there's the same amount of decimal places in both. Now if we take these away from each other, something kind of interesting happens here. We get 9x equals, and 2.33 take away 0.23 is 2.1. Now if we take the same approach as before and turn that into a fraction, so dividing both sides by 9, we get x equals 2.1 over 9. And obviously you can't have decimals in fractions, so we need to remove this decimal from the top, so we can times the top and bottom by 10. And that would give us 21 over 90. There you go, and there's your fraction. And again, you just need to check to make sure that's to see if that simplifies or not. And it actually does. The top and bottom both divide by 3. So you can divide the top and bottom by 3, and you would get 7 over 30. Again, so it might have said show that this fraction equals 7 over 30. But always just check at the end to see if it simplifies. Obviously, if it just said to write it as a fraction, 21 over 90 would be fine. But if it said to give it in its simplest form, we would have to look to simplify there. Okay, so some compound interest. James invests £2,500 for 3 years in a savings account. He gets 3% per annum compound interest in the first year, and then X% for 2 years. He has this much at the end of the 3 years. Work out the value of X. Well, just like normal compound interest here, we can actually do the first year. So we can work out, I'm just going to label this up. So after the first year, let's see how much money he has. So 2,500 for 3%, we would times that by 1.03. Obviously we don't need to add any powers into there because it is just the first year that he's getting this. So if we do this on the calculator times 1.03, and we get an answer of £2,575. Now we've got a bit of a reverse compound interest scenario, and we're going to have to create a little formula for this, because in the second and third year he gets X%. Now his starting number, and let's just write down second and third, his starting number now is 2,575. Now if we knew the percentage, we'd multiply it by that percentage, which we'll call x in this scenario because we don't know what it is, and we'd do that to the power of 2 as it's 2 years. And what it's saying in the question is that gives us the answer £2,705.36. Now obviously at this point here we could just guess some numbers. We could just guess an x value, and if it's too high go lower, if it's too low go higher, and that's a fine way of doing it as well. But you can save yourself a bit of time here just guessing lots of numbers by actually just rearranging this. So we can divide both sides by 2,575, and it will give us the value of x squared. So x squared is going to equal, and again let's just do this on the calculator, 2,705.36 divided by that gives us this answer here, 1.050625243. Now that's obviously the value of x squared, so we need to square root both sides. So if we square root that answer, we get the answer 1.025000118. So that gives us our little percentage here. So it's hidden within this decimal. Now our actual percentage here is not 1.025 because that 1 point is what we increase by for the percentage. So it's just this 0.25 that we're interested in, and 0.25, if you think back to what we did at the start here with 0.3 being 3%, well 0.25 would be 2.5%. There we go, so that's 2.5%. So just be careful that you do read that off there and don't put 1.025 in this type of question. But again, you could have guessed, if you'd have guessed 1.02, it's normally going to be lower than that first one. That's normally what banks do. They give you a better one in the first year and then not so good following that. Okay, so there's just two ways that you can approach that. You can guess some numbers, or you could obviously just rearrange it and find it there. Just being very careful that you actually read the percentage from that 1 point number. Okay, so we've got some surds questions. So 3 plus root 5 squared in the form a plus b root 5, where a and b are integers. Okay, so we need to have a look at this. So that obviously is a double bracket there. So if I rewrite this as a double bracket, we've got 3 plus root 5 and 3 plus root 5. And we just need to expand that now and see what we get. So lots of little surd rules going on in this one. So 3 times 3 gives us 9. 3 times root 5 is 3 root 5. Root 5 times 3 is another 3 root 5. And then root 5 times root 5 is root 25, and it just becomes 5. Remembering similar surds, the exact same surds, when you multiply them together, become the whole number. And if we simplify all this down, 9 and 5 makes 14. And then we can add together these surds in the middle because they both have a root 5. So we've got 3 lots of root 5 and 3 lots of root 5, which is 6 lots of root 5. And there's your answer just there. So A would be 14 and B would be 6. And that is in the form A plus B root 5. And there's our answer with a bit of surds. Let's have a look at another surds question. Okay, so we've got to show that this can be written in this form. Now when we've got surds on the bottom of a fraction, we're always going to look to rationalise it. Now with some of the easier surds, you just times the top and bottom by whatever this root is just here, so by root 3. Unfortunately, that's not going to work for this one because we've got 2 plus root 3. And if we did times the bottom by root 3 there, we'd get 2 root 3 plus 3, and we'd still have a surd on the bottom. So what you do when you've got this on the bottom is you times it by the denominator still, but we change this little sign here. So whatever that sign is, we're going to flip it to the opposite. So we're going to times it by 2 minus root 3. So always write that down, okay, because you do get marks for these elements of your working out. So I'm just going to rewrite the fraction, 2 plus root 3, and I'm going to show next to it what I'm timesing the top and bottom by. So I'm going to times by 2 minus root 3, and I'll put that in a bracket because I'm going to do a double bracket here, and I'm also going to times the top by 2 minus root 3 because we're creating an equivalent fraction here. So it's up to you if you want to put these in brackets as well, just to remind yourself you're doing a double bracket, and then you just need to multiply both of them out and see what we get. So on the top, and I'm not going to draw all over it, I'm going to times them both by the 5 first, and then times them both by the 2 root 3. So 5 times 2 on the top gives us 10. 5 times negative root 3 gives us negative 5 root 3. Onto the 2 root 3, so 2 root 3 times 2 is positive 4 root 3, and then 2 root 3 times negative root 3, and this is the multiplication you always just got to be careful of, gives you 2, I'm going to do it to the side, we get 2 lots of root 9. 2 lots of root 9 is 2 times 3, which is 6. So that number at the end there, and careful because one's positive, one's negative, so we get negative 6. I'll tidy that all up in a sec. Let's have a look at what's on the bottom. Now the whole reason we're doing this on the bottom is to eliminate the surds in the middle. So you can do a bit of a trick when you're doing these. You can just do the first 2, which is 2 times 2, which is 4, and the last 2. So root 3 times root 3 is 3, and it's minus 3. There we go. So that's why our fraction's disappearing, because it's 4 minus 3 on the bottom. Let's tidy up what's on the top. So on the top there we have 6 and the 10. So we've got 10 minus 6, which is 4. We've got negative... Let's do this in a different colour. We've got negative 5 root 3 add 4 root 3. Negative 5 add 4 is negative 1, so minus 1 root 3 or minus root 3. And that's all over 4 take away 3, so it's over 1. So when we're dividing by 1, we can get rid of the fraction there, and we get 4 minus root 3. So there's some surd elements to be thinking about. Obviously there are so many different questions on surds that you could actually have, but there's a couple of things there to be thinking about. The other thing is obviously to remember that surds can only be collected together, like in here, when the number underneath the surd is the same. Okay, so you will have to know how to simplify surds as well, but I've got plenty of videos on that to check out. Okay, so we've got some standard forms, we've got some multiplication and some division. I'm going to start with this multiplication. Now I'm primarily thinking this is like a non-calculator style question, because obviously if this was on a calculator you could just type it in nice and easy and write it in standard form. So actually we're going to have to do a bit of a trick here. So 3.2, I can times that by 4 to figure out what my starting numbers would be. So 3.2 times 4, again, you've just got to work that out whatever method you're used to using. I'm going to do 32 times 4 and hop the decimal back in. So 4 times 2 is 8, and 3 times 4 is 12, and then hop the decimal back in, so it's 12.8. So the answer I get there is 12.8. It's going to be times by 10, and when we're multiplying we can add together the powers here, so 3 plus 4 gives us 7. Obviously though it says to write your answer in standard form, and that number here, 12.8, is not between 1 and 10, so if I hop the decimal in, making the number one place value smaller, I'd get 1.28, and if I make the number smaller, I have to make the power 1 bigger, so it'd be 10 to the power of 8. Okay, so don't be put off by these sorts of questions. Do your multiplication, follow your power rules, and then balance it out. Just remember, if you make the number smaller, you make the power bigger. We'll take this exactly the same approach for this one, except it's a divide. So I need to do 3.6 divided by 4. And again, it's up to you. You can hop the decimal out and hop it back in, but I'm just going to do 3.6 divided by 4 using a bit of bus stop. So 4 doesn't go into 3, so carry the 3, and then 4 goes into 36 9 times. There we go, so it's 0.9. So when we divide that, we get 0.9 times 10 to the power of, and when we're dividing, we can subtract the powers. So the first power there is 2, the second power is -3. So just write that down to the side. What have we got? We've got 2 take away -3, which is 2 add 3, which gives us a power of 5. There we go, so the power is 5. And then again, we just need to balance that out because obviously this is not between 1 and 10. So I'm going to hop the decimal this way, making it 9. So this time I've made the number bigger, so I need to make the power smaller, so it goes down to a 4. And there's our final answer, 9 times 10 to the 4. And the last question on this section. So we've got in 2008, Alice bought a house in 2008, Alice bought a house. In 2014, she sold it for 20% profit. And in 2019, it was sold at a 5% loss. And it gives us the value that she sold it for. Work out the cost of the house in 2008, so right back at the start. So we had 2008, she bought a house. And she sold it for a 20% profit. Then in 2014, it was sold for a 5% loss. And then in 2019, the value of it was 182,400. Right, so at this point in 2019, this cost here to whoever she sold the house to in 2014, this was sold at a 5% loss. So to her, that was only 95% of the value that she bought it for. So if we've got a calculator here, in order to turn that back into 100%, quite nice and simply, we can divide it by 95 to get 1%. So if that there is 95%, we can divide that by 95. So divide by 95, which would give us 1%. So 1% would equal, and we'll just do this on the calculator, 182,400 divided by 95 gives us 1,920. And then to get back to 100%, we just times that by 100. So we can just add 2 zeros on for that. So 1920 with an extra 2 zeros. There we go, so 192,000. So that's the price that it was sold for. That she paid for it before. So before that, it was 192,000. That's not a zero, 192,000. And then we've got to think about the original sale in the first place. So that means that 192,000 there was at a 20% profit. So if that was a profit to Alice in the first place, then to her, this amount of money was 120%. Okay, it was 20% more than she originally paid for it. So we can follow exactly the same approach now. If that's 120%, we would divide that by 120 to give us 1%. So 1% here would equal, and we'll just work that out. Divide that by 120, and 1% is 1,600. And again, you can times that by 100 to get 100%. And our original cost up here would be 1,600 with 2 zeros on the end, so £160,000. There we go, so 160,000. There we go. So that's it using a calculator. That's moving through 2 reverse percentages there, one with a decrease, one with an increase. You just got to remember, if something's been decreased, then we get this 95%, whatever was left over. And then there was also the scenario where at one point it was increased, making it 120%, that extra 20% there. So this can be done calculator and it can be done non-calculator. The 95% one wouldn't be very nice, but thinking about how you could have done this 120%, which is quite common when VAT is added on, because they often have these VAT questions where they say VAT was added on at 20%. There is a way of doing that without a calculator, and what you could do when that happens is you can divide by 12 and then times by 10. So you could do that without a calculator. You could do a bit of bus stop there and divide 192,000 by 12 and then just add on a 0 when you times by 10.